Welcome, everybody. We've already done the Salamat Pagi. Everybody responds in the plenary hall, but it's good to see so many people here. Welcome to this panel. Data center operations, rethinking colo and enterprise relationships in the AI era. But just to be perfectly clear, AI is not chili sauce. We don't sprinkle AI over everything, just like we sprinkle chili sauce over everything. So we just need to control ourselves a little bit when we start to talk about AI. But gentlemen, thank you very much indeed, for joining me. I think the relationship between colo and enterprise can sometimes be somewhat blurred. Sometimes we will have enterprise inside colo, but it brings certain tensions along with it, especially for the colo operator. If you are running a data center operation yourself as an enterprise organization, again, that gives tension. How do you adapt to what the business wants and respond quickly? Because you have the constraints of your existing structure to be able to deal with. First of all, the first question to discuss, what relationship and impact does rack density have on the environment for colo and enterprise? So what is the impact of increased rack density?
I think it's a good point that was brought up because that's the whole reason why people design co-location facilities to ensure there's consistency in the rack density, because we serve a varied amount of customers, co-location customers and also enterprise customers like Iswibowo. So I think that is important because then we're able to, and of course, oftentimes the facilities are newer and it's able to cater to a wider diverse range of customers' needs. So there's some sort of standardization depending on the customer's needs and stuff like that. So I think that's important. So it's able to provide standardized cooling, overcome the weight issues as well that we normally will have because I think we design it. Of course, some of the co-location facilities are newer. So with a newer building, we design for higher rack density. So we're able to cater for this weight issue that Iswibowo brought up, and also we also cater the facilities for newer solutions with cooling down the road and stuff like that. So I think that's the idea and how we cater for that with a higher rack density in line with the demands of the current customers at the moment. In a nutshell, yeah.
Yeah. So thank you very much for that, and it certainly illustrates the tensions maybe that enterprise has in dealing with this. Perhaps turning for a moment to colo, Ka Vin. What are the implications then for co-location when we talk about increased rack density?
Okay, let me frame that question with regards to power. So anything that's under 20 kilowatt per rack is business as usual. So I don't see a major problem. From an operations point of view, so I'm going to frame it correctly, but when you say high density, we are looking today at 50 kilowatt per rack up to about 120 kilowatt per rack. Now we have a significant operations problem. Let me define it as an operations problem, and it is to do with speed, how fast we respond to a problem. And the problem that we are most worried about when you are managing 50 kilowatt rack or 120 kilowatt rack is your failure of your cooling system. The response time before the rack shuts down or burn up, if you're running at 50 kilowatt to 120 kilowatt, my operations team has a total response time to correct the issue in less than 5 minutes. So gentlemen, less than 5 minutes. And today, as a colo data center, it's very big. So literally, you're going to run to the place and you're going to do whatever you need to isolate, shut it down. Because at 50 to 120 kilowatt, it burns up very fast. The heat is very hot. That is the problem.
I agree with that, and certainly gentlemen of our advanced years will not be running anywhere to solve anything.
Oh no, my Indonesian team in Batam is very young. And one of the qualifying factor is how fast they run 100 meters, right? So, no, they can run. The question is, what happened when they get there?
That's the important thing. I think, how does this alter when we get to AI? Because AI is what we're talking about with particularly dense, rack facilities. So what is the challenge then with moving towards AI. Yeah, with a countenance that it's not chili sauce and AI is sprinkled over everything, how do we change the way that we operate when it comes to AI? Ka Vin raises a very good point that the higher the rack density, the quicker, thermal runaway or thermal overload will actually happen, within those racks. So how are we going to deal with that, in either enterprise or colo? What do you think? Perhaps Isbono?
Okay, for the operation itself, for the like the Kevin said, yeah, we must thinking about the cooling system about that one. In our enterprise right now, I said because I know I running the enterprise data center. Because of that, I concerned about that. Right now, we're using the airflow cooling, but if more than 10, right now is only 2 kilowatt until the 5 kilowatt. If we using the AI, we must using more than 10, like a 30 kilowatt. That's need more the cooling system. Right now, in our enterprise data center, we cannot accept that one, follow that requirement. That's it. Because of that, maybe we consider about put it at the co-location.
I think that's a good point, that you need to understand what your facility is able to deal with and how you deal with the demands for increased capacity and for the use of AI. You maybe need to transfer to something else, such as our friend Ka Vin here and one of his facilities, to be able to cope with the increased demands, because your air is only good up to about 20 kilowatts.
I think it's a good point. I second what Ace is saying. I think we're going to know what our capabilities are and what our limitations are. And that's the whole idea of having co-location facilities, because we're able to cater for these needs, right? So yeah, I think in our data center in Batam, which we just inaugurated sometime in February this year. So it's the same idea. I think we're able to cater to that. It's a newer facility with AI coming in. Obviously, like what Ace was saying, the traditional data centers will be 2 to 5 kilowatts, typically especially for enterprise. I think now with AI coming in, you're probably looking at, of course, people are banding ideas of 50 to 120 kilowatts. But I think what is more practical, what we're seeing now in the market is maybe something about 20 odd kilowatts. That's the sort of range we're seeing in the market. So those are the needs. I think it comes up to things like thermal, one issue, power is another issue. Oftentimes with AI coming in, the rack density used is much higher, and that results in, depends on standard density of your racks, probably end up using more power, and you're probably having surplus racks because you're not able to utilize the rack space, right? Because there's just more power is consumed because of the higher power usage of the GPUs that are being deployed by NVIDIA and stuff like that. So I think that's the trend that we're seeing. So I think we got to cater for the power. How do we can increase the power if we need to cater to that? That's one. Of course, there's implications to that with the PDUs coming down, and of course, main thing is thermal solutions. I think if those in typical enterprise data centers, I mean, you're probably limited to air cooled, but we think of alternative solution, maybe, I don't know, rear heat door exchangers, sort of way to sort of compensate, to take care and to remove some of the heat, so they're able to deal with those situations as a temporary solution of sorts until we can go into something better. Yeah, but it's a temporarily permanent solution of sorts, if I may put it that way. Yeah.
So basically what we're saying there is enterprise is going to outsource all of the risk.
Thank you. Let me break this down. Your definition of AI is very broad. I like to break it down, otherwise I can't answer the question. There are two types of AI. Number one, it's a large learning model. You don't have it in Asia, and you're unlikely to have it in Asia unless it's a sovereign model, which means it has to be in-country, run by government. The other ones, which are being built by the likes of Microsoft, AWS, Google, Oracle, whatever, if they're running a large learning model, these are very high density. They're going to be running the latest version of the NVIDIA chip, and they're going to be very high concentration in one data center, 30 to 100 megawatt data center. That's what they need to run what we call a large learning LLM. So let's take that out, because that's not going to be the colo business. So what we are involved in the colo business worldwide, all colo player, will be to be involved with AI application or AI inference. AI inference is a completely different thing. It basically links to the application itself. For example, a completely AI-run hospital where you have no human doctors. All the doctors are robotics, intelligent AI machine, and they need inferencing, not large learning model. Or like in Singapore, an entire car factory that you can find in Tampines, 8-story car factory built by a Korean company, and in that car factory, they're generating the iconic 6 or 8, I don't remember, that comes out of that factory every day. There's no human in there, just car manufacturing robots. The only human in that building is about 30 robotic engineers to service the robot. So let me put that into perspective. In that sense, that's the application space for colo players like us or anyone else to address. So when you talk about that, the interesting thing would be at the basement level, we are talking today to a lot of GPU service provider, because at the bottom end of this group of people are what you call GPU service provider, and all the AI application will buy the service from them to operate their application. So herein, we have had numerous discussion, in-depth discussion, and the unique thing is the rack arrangement and its connectivity to the network. It's very unusual, it's very specific, which means you've got to pay detailed expense, you've got to pay a lot of detailed interest to sitting down with that particular company to understand how to optimize the network connection. It will impact your meet-me room design completely. So this is something we learned, and these are things that as a colo provider, we now need to pivot, and we are no longer dealing with an internet exchange. We're dealing with an AI requirement that needs connection between the network and their rack design. So it's interesting times for colo providers.
And I think Vincent is paying extreme attention here in looking at maybe next year replacing us with a generative AI model. He's not paying attention though. Vincent, you're replacing us next year with a generative AI model, I understand. Okay, so there are a couple of other concerns with engineering in looking at AI, Colo and enterprise. We talked about weight, and we always think of weight as being imposed on the floor. What we need to remember is if you've got a multi-story building, there is weight imposed on the underside of that floor as well. So that needs to be taken account of. If we're moving to immersion cooling baths are also heavy. So how do we deal with that? The heat rejection we're not particularly considering right at the moment. In the tropics, we have more heat than we actually know what to do with. But there are different solutions we can use for heat rejection and how we reuse that heat elsewhere. Briefly, what are any other engineering concerns that we may need to consider, apart from increased staff with a 0 to 100 meters time span of under 5 seconds?
I think it boils up to the same thing with regards to putting that in with the AI. I think it ultimately boils down to power, cooling, and maybe space. These are the three main things. I think space consideration as well. I think on top of just weight, I think we're looking at situations where the space provided for cooling and power solutions are bigger, whereas the white space is getting smaller, the gray space is getting bigger. That's what we're seeing in the trends. Maybe it used to be 1 megawatt takes 1,000 square meter of white space. Now is 1 megawatt takes about 800 square meters of white space. So that's a trend that we're seeing in the market at the moment, with more higher density stuff being deployed. So I think that's one of the considerations besides the usual power and cooling, which what you're saying about immersion cooling and stuff like that. I think those will be implications to the weight as well. The floor weight that you're building used to be building maybe about 1.5 to 2 tons. Now you got to increase it to more to cater for things like that. So I think there will be cost implications to that as well. And if what Ka Vin is saying, we need to do inferencing downtown in a more centralized edge location. The impact of that on the build cost because of the weight, there will be a price consideration that will impact the return on investments as well, from our perspective as a colo provider as well. Yes.
Okay, thank you. Iswibowo, very, very quickly.
Yeah, for the enterprise, this is impossible if we right now implement for the immersion cooling system, because to huge change in our environment right now.
To answer your question on the technical challenges of liquid cooling, yes, there is. In terms of operations, we're already seeing it. I think mostly in Malaysia and most of the economy that's running cooling to the chip, right? The issue is with leakage. Okay, liquid. Because the current water cooling system is based on positive pressure. We have CDUs that apply positive pressure, and we push the water into the entire circulation. That creates a lot of pressure points in all the connectors. you have on your racks where the water gets to the narrow down. So we are seeing that when you run this system in a constant day-to-day manner, 24/7, 1 year, the joints will start to give way because of the constant water pressure. So we have to deal with water pressure. It's very hard to deal with that. So I have been talking to vendors, and this is something that is done in the United States today, is a technique called negative pressure. So we are looking at negative pressure water system to enable us to ensure that we can maintain the system better. That's the engineering challenge of the future.
Great. So thank you very much indeed for that. I'd like to thank our panelists for joining me in this discussion. It's been most interesting. So thank you very much, and we'll hand back to Brendan.